Okay, guys, this is the second problem from chapter 6.1. This problem comes from the book. It's from page 261, and it's problem number 5, part B. We'll start by defining two sets. The set capital C is equal to the set containing all elements C that are integers such that C is equal to 6r minus 5 for some integer r. And the set capital D is equal to the set containing all elements D that are integers such that D is equal to 3s plus 1 for some integer s. And we are tasked with trying to prove or disprove that D is a subset of C. For anyone that looked at 5a, it was just asking a different question. 5a was asking if C is a subset of D, and now we're asking if D is a subset of C. Please pause the video and try this problem on your own. And when you're done or hit a wall, go ahead and unpause the video and I'll show you how I did it. Okay, I'm going to get started. I will always start with an aside with these proofs. I'm going to select a variable that's not in any of my definitions as a distinct member of one of the sets. I'll say M is a member of, or is an element of the set D, right? That's on the left-hand side of the subset symbol. If M is an element of D, then that means that M is equal to 3s plus 1, where M and S are both integers. And so over here on the side, I'm starting with the form 3s plus 1, and the form I want to look at is 6r minus 5. The first question I'm going to ask is if the leading coefficient of the left-hand side is greater than or equal to the leading coefficient on the right-hand side. It is not. So I need to multiply the expression on the left-hand side by some number so that it's greater than or equal to. Well, it's simple. I can just multiply by 2 times 3s plus 1. And that's equal to, 6s plus 2. Okay? So I know some integers can go in my parentheses, but what goes on the outside of the parentheses is this minus 5. So I'm going to put minus 5 out here. And then ask the question, how do I get from minus 5 to 2? Well, I have to add 7. 7 minus 5 is equal to 2. I leave the 6s alone. And now I ask the question, can I factor out a 6, which is this number here, from inside the parentheses? Well, I cannot without making it not an integer, right? So it would be 6 times s plus 7 over 6 minus 5. But 7 over 6 is not an integer. So this statement is false. We're going to be disproving it. Okay? So how we're going to disprove it is we're going to find a counterexample. I'm going to start with my left-hand side. I'm going to just plug in 1 for s. This may or may not work. We're going to find out if that's a good counterexample. So I'll say that 3 times 1 plus 1, well, that's equal to 4. And 4 is the counterexample, not 1. So it's easy to get confused about what is your actual counterexample. The counterexample here is 4. And so now I'm going to take my right-hand side expression and set it equal to 4 and see if r is an integer. So that's 6r minus 5 is equal to 4. 6r is equal to 9. R is equal to 9/6, which is equal to 3/2, which is not an integer. So I have found my counterexample. The counterexample is 4. So now we're going to do our proof. I'm going to say false. And how I'm going to word this is 4 is an element of set D because 3s plus 1 is equal to 4 has an integer solution of s equals 1. However, 4 is not an element of set C because 6r minus 5 equals 4 does not have an integer solution for R. Thus, D is not a subset of C. QED. And we're done.